Welcome to this session. Thank you for choosing this session and spending a bit of time with me. In this session, you're going to learn why and how you can use IPv6 with an elastic Kubernetes service cluster. That's a big topic. IPv6, IPv4, Kubernetes, and how they work together in the cloud. So my name is Sébastien Stormac. I'm a principal developer advocate based in Paris. I wrote a blog post that actually announced the availability of that functionality of EKS. And in this session, I'm mostly going through a very basic demo to create a cluster together, to configure it for IPv6, to deploy a small application on it, and to show you that IPv6 connectivity works as expected. But first, you're going to ask me why. Why do I need IPv6 for your cluster, for your EKS cluster? And there are a couple of reasons to do that. One of them is the limited address space. You know that in IPv4, you have 32 bits to express your network. So in theory, it's up to 4 billion IP addresses, but of course in a VPC you might be limited to /16, so it's much less than that, plus a couple of reserved IP addresses as well. And in a very large EKS cluster where you have a lot of pods and a high density of pods on your EC2 instances, you might run out of IPv4 address for your pods or for your containers running on the cluster. And the reason is that Kubernetes choose to implement the network as a flat network model, which is a good thing. For many aspects, it was a great decision. It makes migration easier. You don't have too much, I'm talking with quotes here, network complexity at EKS level because of that flat address space. You don't have to define special routes or subnets and things like that. But because it's flat, you have to fit within whatever is provided by the host, and the host on AWS, it's an EC2 instance, it's run on a VPC, so you are limited by the size of a VPC, which maximum size is /16 minus whatever segmentation you create at subnet level. So the first reason to use IPv6 is pod density. If you have a large number of pods, you might want to run IPv6 instead of IPv4. And there are workarounds. If you don't want to use IPv6, you can create at the container network interface layer, at the CNI layer, you can create like a virtual IPv6 network for your pods and then map that to IPv4 address on the host. But that's additional complexity. You don't want to go there. I think Kubernetes is complex enough to try to keep it simple as much as possible so that you don't add complexity on top of the complexity. Another reason why you might want to actually use IPv6 is latency. Imagine that your pods are calling native IPv6 APIs or services. If you run on IPv4, you will need to go through some kind of NAT translation between IPv4 and IPv6. And any NAT translation will increase the latency to call your services. So if you are calling native IPv6 services, it's much better to do that from an IPv6 client, a Docker container running on Kubernetes on IPv6 to avoid having any additional latency for your host. So why IPv6 is there? First, it's not new, IPv6. I bought my first book talking about IP next generation, as it was called at the time, in 1996. So more than 25 years ago, 26 years ago, actually. And since then, adoption is becoming much more popular now. AWS adoption of IPv6 starts a couple of years ago. We start with edge services, with CDNs, and then we went to load balancer. And now you can have your VPC as IPv6 only. You can have IPv6 only EC2 instances, and IPv6 is coming to more and more of our services. IPv6 has 128 bits of address versus 32 for IPv4. That's a huge difference. So it's 3.4 multiplied by 10 exponent 38 address in theory. And that's a lot. Actually, if you assign an IPv6 address to every single atom on this planet, you have enough to fill in this Earth, but also 100 other planet out the same size as planet Earth. Benefits of IPv6, I told you, higher density and lower latency. That's it. Enough talk. Let's try to get started, and let's try to move and show you a demo how it works. So the starting point is a VPC. It's a network. You need to create your VPC and to configure your VPC to allocate an IPv6 CIDR block. And I did that with a CDK script. You can find the CDK script on my GitHub, and you will receive the reference to the GitHub at the end of this presentation. So here I am in the VPC console. On my Isengard account, you see the VPC is already created. It has a CIDR block. It has been allocated. Notice it has also an IPv4 block, and I will come back to that in a moment, but the nodes in your cluster needs to be dual stack. They have to have an IPv4 and an IPv6 address so that the EKS service can talk to the node inside your cluster. I'm not going to go too much into the details of that VPC. Next step, I will use the command line to create a cluster and to create a cluster and to create the node, and then to deploy an application and check the connectivity to that IPv6 only application. So to help me with the command line, I will first position a couple of environment variables. I need a role for my cluster. I need a role for my EC2 nodes as well. These roles exist already. They are there. And let's have a look at this role. I have a role for the cluster and a role for each individual node. So let's go back to the console and switch to IAM. Inside IAM, I can search for my EKS role. The cluster role and the node roles, I create them myself. They are not there by default. You need to create them in your account. The cluster role allows the EKS service to interact with EC2 and the load balancer. So it has a trust relationship defined to EKS. So it means the EKS service can assume that role, and the permission is one of our sets of managed permissions. So I didn't write it myself. It's a managed policy, and you see it's everything related to autoscaling, EC2, and the load balancer. That's how EKS can talk to these services. The other role that you need to have, it's a role attached to each EC2 node, and again, it will be assumed by the EC2 service, so the trust relationship is set on EC2. And then on the permission side, you have a managed policy, which is worker node policy, that allows the node to describe the instance on which it is running. So all the describe things from EC2. Most probably you are going to pull out Docker image from the container registry. So you have to have the ECR groups of authorization permissions that lets the application running on the EC2 host to interact with Elastic container registry. And then specifically for IPv6, you need to create a policy. And I create that policy myself. It's not a managed policy. I just copy paste the permission from the documentation. I didn't invent anything there. But that's the permissions that are required when you're deploying IPv6 pod on your cluster. So basically, it allows the EC2 host to assign an IPv6 address and to tag the network interface it's going to use. So once you have these two, I will assign them to environment variable, because that way I will be able to cluster. What's my environment variable? It should be cluster role ARN. Yeah, cluster role ARN. So that way I will use the CLI much more easily. So that's the ARN for my cluster role. And node role ARN equal this. So while I am there, I will also define a cluster name like seb demo, for example. And I need to assign also environment variable for the subnets I want to use. So the subnets have been created already, but let's query the subnet ID for my public subnets where I'm going to deploy my cluster. So I first search for the VPC ID. It's an EC2 describe VPC, and I filter on tag values and I search for the VPC ID. Once I have the VPC ID, I describe subnets for that specific VPC ID, and I just extract the subnet. So now I can create subnet 1 equal this, and subnet 2 equal that. I think with that I have all the environment variable I need to actually create my cluster. I will create the cluster. First, I will verify that my subnet will automatically assign an IPv6 address on the creation of an EC2 instance, and it's the case. I have that flag through on all my subnets, the public and the private one. I just need a public here, but just to be sure. So that's good. And now I can create the cluster. So what are the important options when you create the cluster? First, EKS create cluster. You give the cluster a name, a version. At the moment I'm recording this video, April 2022, it's 1.22, which is the latest version of the cluster. The role ARN that you create, the subnet where the nodes are going to be placed, endpoint public access and private access is the same with IPv4, IPv6 didn't change, so here I choose true for the two. The important thing is the last one, IP family IPv6. By default it will go to IPv4, and that's something you can only choose at the moment you create the cluster. So if you have an IPv4 only cluster, there is no migration path right now. You need to create an IPv6 cluster and then migrate your application to the IPv6 cluster. Okay, now that I have the cluster, next step is to create the node group. So the node group are the EC2 instances where EKS or Kubernetes is going to deploy your pod. The node groups, it's based of EC2 instances and it's managed by an autoscaling group. The autoscaling group, you don't need to create it yourself. The EKS is going to do that. The command is AWS EKS create node group. You give the name of the cluster, the name of for node group, the node role that we checked already before, and the playground where should I deploy these nodes. And these are my two subnets. It will take a bit of time, the time to create the autoscaling group, that the autoscaling group creates the EC2 instances, to register the EC2 instance to the Kubernetes control plane. You can monitor the status with describe node group command, and it takes like 5 minutes to get my two hosts running here. You see I'm running Amazon Linux on x86. The node role is there. My subnets are there. By default it goes to a T3 medium, but you can change the launch template. And right now it's creating, it will create two instances for me out of a group that vary between 1 and 2 instances. So let's wait a bit for that to be created, and I'll join you right after the break. Oh, you're there. You're already there. Thank you for coming back after the break. I was waiting for the node group to be created, and it took like 5 minutes. If I do a search now, a describe, I receive status equal active. And to confirm that, I can go to my EC2 console, and you see I have 2 nodes, and things are well done because they are running in 2 different availability zones. And these are managed by EKS for me through an autoscaling group. Notice that these hosts have a dual stack, so they have both an IPv6 address and an IPv4 address. And this is actually required for Kubernetes IPv6 pod, because the EKS service still talks through IPv4 to the nodes, but it's only the nodes, the EC2 nodes, not the pods that are going to run on top of these. So what are the next steps? Next step is actually to deploy an application. No, maybe I can first confirm with the command line. You know that I love the command line, that my two hosts are running and they have an IPv6 address. So I'm here describing instances. For all running instance, take the network interface IPv6 address, and I have my two EKS nodes plus a host I'm going to use to test the connectivity a bit later on. Okay, what from Kubernetes point of view? If I type kubectl get nodes, I should see the same nodes from the Kubernetes control plane as well. And yes, you can see that I have my two nodes there. If I use the -o wide option, I think I should see also the IPv6 of the nodes, which we are not going to use in this demo, and also the IPv4 of the nodes. It's there and there. Okay. Next step is to deploy an application. So the application I'm going to deploy is a simple Nginx server, and I'm not going to try to create something from scratch in front of you. I'm really bad at that. So I have a deployment file already there. So it's a deployment on Linux. It's a sample Linux app, that works for AMD and ERM, and the container I'm going to use is the standard Nginx container that is available in the public container repository from AWS. So it's 1.21 version. It will listen simply on port HTTP, and that container is just an Nginx server with a static page saying, hey, Nginx is started. So nothing too complicated, but I will show you that I can access that through IPv6 and IPv6 only. So to get started, let's create first a namespace, nothing related to IPv6 here, namespace. Let's call it sub demo. So that's my namespace. Let's deploy some pod there. So kubectl apply and my pod file. So that will create two pods, two or three pods. Oh yes, EKS sample deployment block not fonts. It's because the name is not the same. I changed the name. So let's quickly change the namespace to up sub demo. To show you that the demo, even if this video is pre-recorded, the demo is pretty much live. So kubectl get pods on subdemo, and maybe we can ask for more information, and we should see 3 pods that have been created, and they all receive an IP address. So I should have 3 Nginx server there. So to contact them, I can use curl. If you want to use curl with IPv6, you need to specify -g-6 HTTP. And then because I am in bash, I need to escape my square bracket, but that's only a bash thing or shell things. I'm not in bash, actually, I'm on ZSH. And here I'm from my laptop. I'm recording from home, as you can see from my background, and my great ISP provider, internet provider at home doesn't give me an IPv6 address, so I cannot connect to that IPv6. And notice that my pods have no IPv4. The underlying EC2 instance has an IPv4, but the pods themselves, they just have an IPv6 address. They have, a DNS name, internal DNS name, but that's internal inside the VPC, so it's not accessible from there. So if I want to try the connectivity using IPv6, first I'm going to copy paste that command because I don't want to repeat that command. But what I did is I create an IPv6 only host inside the same VPC as the worker node. That's the third instance, the demo IPv6 only, which is running there. and you don't have to believe me. You see, it has no public IPv4 address. It has only a public IPv6 address. It has a private IPv4, but I cannot connect through private anyway. I associate SSM and SSM connectivity there, so I can connect through Session Manager. I love to do that because I don't need a security group. I don't need an access key. I don't even need an IPv6 address. I can just connect through my browser to an instance. This is a real IPv6 instance. The proof is I can ping Google, for example, in IPv6. And don't try to do that with www.amazon.com. Looks like we are not exposing our endpoints with an IPv6 address yet. That's why I show you Google here. So let's try to reach out to my Nginx container. I paste the command curl -g-6 and the same IPv6 address. And it's not working. Of course, it's not working. Why? Because of security groups. Remember that the nodes have security groups, and the security groups authorize communication only if it is coming from the same security group. So let's change that. In the security group is there, and you see it only accepts request if it is part of the same security group. So if the source is in the same security group. So I'm going to change the security group of my jump host, of my EC2 instance, the demo EC2 instance, and to put that EC2 instance in the same security groups as my host. So change security group. I remove the old one that doesn't exist anymore. And I put the SEP demo security group there. Let's add the security group and save. And now this instance is in the same security group as that one. So the network traffic should flow in between the two. And yes, curl returns the default HTML document of Nginx. You see that, hey, welcome to Nginx. So I have an IPv6 communication towards an EC2 instance and one of the pods running on my EKS managed Kubernetes service with IPv6 on AWS. That's the end of the demo. So I show you how to create a cluster on a VPC IPv6 network, how to create nodes on that cluster, and how to deploy an application. And there are a few things that I would like you to remember. First, IPv4 versus IPv6 choice. It's made at cluster creation time. So there is no migration path as of today. It's when you create your cluster that you define if the cluster will be IPv6 or IPv4. I'm talking about the pods running on top of the nodes, because the nodes themselves, they have to be dual stack anyway. So the nodes, it's always dual stack IPv4 and IPv6. I show you everything on Linux because we don't support Windows yet. So right now it's a Linux only thing. Keep that in mind. If you want to dive a bit deeper, I wrote the announcement blog post, so you can read the blog post, which is basically a text version of everything you saw in the video today. And I created a QR code there. With love, you can flash that QR code and go directly to the URL of my blog post. For those of you that wants to go much deeper into the subject with way more details that I am able to provide to, the service team also wrote a more detailed blog post that has been published at the beginning of January this year, 2022, on the container blog post. A lot more details and definitively something to read if you want to work with customer deploying on IPv6 EKS. And again, there is a QR code there that you can use to go to that blog post. So thank you for having watched this video and the demo until the end. I hope it was informative enough. You can follow up with a Q&A. There might be a live Q&A question, Q&A section, sorry, right after this video. So stay tuned if it is the case. And if you're watching this video in a place where there is no Q&A, that might happen as well, you can always reach out to me on social network, Twitter and LinkedIn. All my code sample is there on YouTube, on GitHub, sorry, and on YouTube/Sepsto. There are more videos like that in French and in English. Thank you for having watched this demo and this video until the end, and see you soon.